Take a walk down any city street, and you'll pass hundreds of metal light posts. They endure daily exposure to pooling rainwater, winter de-icing salt, and dogs relieving themselves during their afternoon walks. We often treat these things as minor sanitary issues, but at the street level, they combine into a highly corrosive chemical mixture that constantly attacks public infrastructure. This diagram shows a cross-section of a steel light pole under attack. Uric acid from animal waste and chloride salts from winter treatments penetrate the surface, chemically breaking down the metal's structural lattice and degrading the concrete base beneath it. The bottom 12 inches of every street lamp and signpost in the city is an active, microscopic battleground, and right now, local authorities are losing. When the base of a structural pole rots away, patching it isn't an option. The entire asset has to be taken down and replaced. For local authorities, swapping out thousands of heavy steel poles acts as a massive drain on maintenance budgets that could be spent elsewhere in the community. This flowchart maps the hidden environmental toll of that decay. Replacing a single rusted street lamp requires heavy industrial manufacturing, forging new steel and mixing fresh concrete, plus the deployment of heavy-duty diesel vehicles to install it, outputting massive amounts of CO2. Public infrastructure decay is a continuous, high-carbon industrial cycle that directly harms the global environment. To break this cycle of decay, we have to look at preventative protection. That is where Peat Guard comes in. Peat Guard is a discrete physical shield designed specifically to intercept corrosive liquids and redirect them away from vulnerable surfaces. Its shape does the heavy lifting. The uniform, ridged exterior prevents liquids from pooling against the metal, forcing immediate runoff to the ground. Because the barrier handles the harsh chemicals instead of the pole, these locations stay significantly cleaner and become much easier for municipal crews to wash down. By stopping the initial contact with corrosives, the shield effectively pauses the premature aging process of the infrastructure. This creates a specific engineering challenge. What material can sit outside, endure freezing weather, and take daily hits of uric acid without breaking down? The answer is recycled plastic, but specifically the plastic rejected by almost every other industry. This process flow illustrates the recycling divide. High-grade plastics are easily melted down for clothing or new food packaging. Peat Guard is manufactured using low-grade, post-consumer plastic, materials normally destined for landfills. The chemical irony is that the dense, stubborn molecular structure that makes these plastics impossible to easily recycle makes them entirely immune to urine degradation and outdoor elements. This manufacturing process turns an environmental liability, unrecyclable plastic waste, into a highly durable protective asset. When you scale this preventative defense across an entire urban grid, the positive environmental and financial impacts begin to rapidly compound. First, massive volumes of unrecyclable plastic are permanently rescued from landfills to forge these shields. Second, local authorities preserve their high-value public assets, saving significant maintenance funds over the infrastructure's lifespan. This comparative chart shows the simultaneous reduction in 3 key metrics. By cutting the frequency of infrastructure repairs, we drastically reduce the carbon emissions associated with raw material manufacturing and heavy municipal maintenance, while also dropping landfill volume and municipal costs. Creating an interconnected reduction across multiple sectors is the definition of a sustainable closed-loop system, where solving a waste problem in one area solves a resource problem in another. Peat Guard provides this highly specific and targeted solution for protecting our critical highways. Achieving ultimate sustainability always requires highly practical engineering. Sometimes the best way to protect the infrastructure we already rely on is to creatively weaponize our waste.